So the question here is graph the inequality. And to graph the inequality means to show all the solutions, because the graph is actually something that includes all the possible solutions. So we're trying to see where are the possible solutions of this inequality. Okay, so the inequality is x plus 4y is bigger than or equal to 6. So here the solution is two parts. The first part, or the first step, is to graph the equation x plus 4y equals 6. If you graph this equation first, and then after that, we'll see what is the second step. So how do we graph this equation? We build a table of values, and then we plot these values, and then we connect them together as before. It's just like a line. This is a linear equation. The powers are 1. Whatever the powers are, you just need to graph this. So you're going to build a table of values, x and y. Okay, for different values of x, you're going to calculate y. So suppose x, for example, is 0. When you put 0 here, then 4y equal to 6. And that means y is equal to 6 divided by 4. 6 divided by 4 is 3 over 2, which is 1.5. Okay, so this will be 1.5. Okay, so I just had 1 point. Let's choose some other values for x. Maybe I'll choose 2. It looks like choosing even numbers will be easier because everything is even here. So if you choose 2 for x, the value of x is equal to 2. So you just put 2 here, and then if this is 2 here, you just move this 2 to the other side, become minus 2, and 6 minus 2 is 4. So you have 4y equal to 4, so that means y equal to 1. That means y equal to 1. Okay? Suppose I want to choose some, if you want to choose some negative values, you can also choose some negative values if you want. Suppose I'll choose, for example, minus 2 this time.
You can choose values for y, right?
Yeah, yes, you can choose some values for y. You can put y equal to 0, for example. Let's just put y equal to 0 here. Okay? So maybe I choose y equal to 0, because usually the intercepts are good points. Put x equal to 0 one time, put y equal to 0 one time. So if you put y equal to 0 here, this disappears completely, and that means x equal 6. Okay, so I have x equals 6 here. Okay, and that's it. Now I have a table of points. That's enough. I can plot them now and see how does it look like. Okay, here is my graph. 0 and 1.5 is approximately, suppose this is 1, 2, 3, 4, 5, 6. So 0 and 1.5 will be here. Okay, right? And 6 and 0 will be here. Suppose this is 1, 2, 3, 4, 5, 6. So 6 and 0 will be actually here. Okay. 2 and 1 will be somewhere like that. 2 and 1 maybe will be here somewhere. Anyway, if you connect all these together, this will be the line. So this is the first part. The first step is to graph this line. Just convert the inequality to equation and graph this equation, which is a line in this case. Linear equation. Linear because the powers are 1. Any question about that? First step. The second step, step 2, is to find out where is the shading. The shading. Okay. See, this inequality, the solution of this inequality is either the upper part or the lower part of the under the line. So it's either above the line or below the line. So one way to know where is it, okay, so is to make a test point, not on the line, here on that side or in this side. Okay. Usually, if the line doesn't pass by 0 and 0, the origin point, then usually we take this as a test point because it's very easy to use it for testing. Okay, so obviously the line here is not passing by this point, so I will use it. I will use this point as a testing point. So that's why I'm going to test this point 0 and 0, okay, and find out what will happen to this inequality. So this inequality, when x is 0 and y is 0, what will be the left side?
0.
Everything is 0, right? 0 plus 4 times 0 is actually 0, isn't it? And then the other side is 6. And then you ask yourself, is this true? Is 0 greater than or equal to 6? Of course, this is false, right? This is not true. 0 will never be bigger than or equal to 6. So if it is false, means this test point is not part of the solution. So where is the solution now? The other side. The other side. So that's why I will shade the other side. That's it. The solution is here. The solution is here. This is the other side. Okay? Now, what if you test the point and then this turns out to be true? Yani some other values and it's true. If it is true, then you should shade the area of this test point. You know, the region of this test point should be shaded to represent the solution. Okay? Any questions? The first step or the second step? The second step, the graph of this inequality here is a region. It is not a line. It is not a curve. It's a region shaded. It's part of it's a region that, you know, part of this plane, this whole, you know, XY plane. So which region is it? We make a test point to find out. Any test point you choose. You choose this point here, like for example, this is 6 and 2, or this is maybe 5 and 5, this is maybe, I don't know, -1 and -1. Choose any test point, but not on the line. Okay? So I choose a 0 and 0. And when I choose 0, 0, I substitute. I want to know, is this point a solution or not? Because if it's a solution, it should be shaded. If it is not a solution, it should not be shaded. Okay? So this point 0 and 0, I put this 0, 0 here, 0, and here 0. Okay? So 0 on the left side is not bigger than 6, right? So that's why it is not solution. If it is not solution, then the other side is a solution. So I find out when I test the point, if this point satisfies the inequality and make it true, then this point part of the solution. If this point does not satisfy the inequality, then the other side is the solution.